or it may clear up questions about how the trap station has performed under certain operating conditions. After a steam trap station has been surveyed or inspected, the next step is to survey the individual traps in the station. Trap problems aren't always easy to detect, so a combination of different inspection methods may be used. Typically, a thorough trap survey combines information obtained by performing 3 types of inspections: temperature, sound, and visual. A temperature inspection is usually a good starting point for a trap survey. The temperature at the trap's inlet and outlet pipes should be in the normal range for the specific trap installation. Generally, the inlet should be hotter than the outlet, but if the outlet is cold, it could indicate that the trap has failed closed. Whatever method you use for a temperature check, you must be able to interpret the meaning of the information that you obtain. For example, a properly functioning steam trap is usually warm because live steam is unable to escape from the trap, while a cold trap is probably not working. However, a trap normally operates somewhat cooler when it's working properly than when certain malfunctions occur. For instance, a significant increase in the temperature of the trap could indicate that the trap has failed open and live steam is escaping. If the trap inlet temperature is in the allowable range, trap inlet conditions are normal. But this doesn't mean that the trap outlet conditions are also normal. Outlet conditions must be checked separately. If the temperature at the trap outlet is also within the allowable range, trap conditions are probably normal for the temperature inspection part of the trap survey. Trap surveys based on differences between trap inlet and outlet temperatures can be inaccurate in certain situations. For instance, if a series of traps are installed on a manifold setup so they discharge to a single return line, back pressure may rise because of faulty traps. But the back pressure will rise on all the traps in the system, good and bad alike. So a temperature inspection alone probably won't give reliable information about the condition of a specific trap. On the other hand, in piping systems that have sufficiently large return piping, a failed trap may cause no rise in back pressure, and the temperature differential would remain unchanged. So this is another situation in which measuring the temperature differential across the trap won't detect the trap failure. Another type of trap inspection is a sound inspection. It's performed by listening near a trap's outlet for mechanical sounds and flow noises that are associated with the operation of the trap. To perform an accurate sound inspection, you generally need to use some type of listening device. The device carries the sound from the trap to your ear and helps filter out background noise from other traps, pumps, and similar equipment that can make it difficult to obtain a reliable reading. Even with the help of a listening device, filtering out noise is especially difficult if several traps in a manifold discharge to a single header, because sound can travel from trap to trap through the piping, and a good trap could be telegraphing or conveying the signal of a malfunctioning one. So if you detect the sound of a malfunctioning trap while you're performing a sound inspection at a trap manifold, keep in mind that the failed trap is usually the one that's producing the loudest signal. However, not even the most sophisticated listening device can help you detect trap problems if you don't know what sounds you should be listening for. Each type of trap has its own particular sounds during normal operating cycles and during failure. With training and practice, you'll be able to recognize the differences between the sound of a trap that's discharging normally and one that's not. Also, when an ultrasonic detector is used to inspect a steam trap, the frequency response of the detector may vary by model and manufacturer. These variations can affect the actual sound that you hear from a trap. But listening to a few examples of typical trap sounds will give you some guidelines that you can apply on the job. A visual inspection can be a very informative part of a steam trap survey. But as with other types of inspections, you need training and practice to be able to perform the inspection effectively. Begin by simply looking over the trap for condensate or steam leaks. Leaks typically occur at piping connections and at the steam trap's body-to-bonnet connections. Next, see if live steam is being discharged from the trap. This is relatively easy to determine if the trap discharges to the atmosphere. Of course, before you can determine if a trap is discharging live steam, you must be able to recognize the difference between flash steam and live steam. Flash steam is a normal condition in which vapor is formed when hot condensate is discharged from a trap. Normally, the discharge from a trap consists of a center core of hot condensate with a slowly moving white cloud of flash steam circling the outside. Live steam is produced in the steam system's boiler. It's usually discharged with more force than flash steam is, and it has no center core of hot condensate. If it's working properly, a steam trap should be discharging hot condensate with some flash steam. But if it's discharging live steam, the trap isn't working properly, and it must be repaired or replaced. If the discharge is intermittent, the cycle rate should be timed, and the time should be compared with the cycle time that your facility or the manufacturer lists as normal for that particular trap. Different traps have different discharge cycle rates. Disc traps, for example, are designed to discharge intermittently, so a continuous discharge could indicate serious problems. Float and thermostatic traps, on the other hand, are designed to discharge condensate continuously, as long as there's a constant flow of condensate into the trap. And although an inverted bucket trap usually discharges condensate intermittently, it may have a constant small discharge if it's operating at a very low percentage of its rated capacity. This condition is sometimes called dribbling. By combining the information you get from performing temperature, sound, and visual inspections that you make during a trap survey, you can get a good idea of how well a specific trap is working. Trap surveys should be performed on a regular basis. A trap's size, pressure, and workload will determine exactly how often a survey should be conducted. Keep a record of trap performance as an aid for determining if a trap has a high failure rate. A trap that fails several times within its normal service life should be investigated. The failures could be a sign that the trap was installed incorrectly, or that the wrong type of trap is being used for the application.